Today we look at understanding acceleration. What is acceleration? Simply means the rate of change, velocity. And graphically, if we want to describe acceleration, we talk about the velocity time graph. That is plotting velocity on the y-axis and plotting time in seconds on the x-axis. Most of the time, students want to approach this question and they will not know what to do. So this question seems to be complex, but it's very simple. Now this graph is divided into A, B, C, D. And the journey on the y-axis is from 0 to 25 meters per second. Time is from 0 to 50 seconds. So the car, assuming this is a car, starts this journey from rest. The resting position, that is 0 position, and move to 15 meters per second within 10 seconds. So we can calculate acceleration for A. And then from this point, it maintains a constant velocity. At this point, the velocity did not change. And remember, we defined velocity acceleration as the rate of change of velocity. So if there's no change in velocity with time, the acceleration becomes 0. That means that from 10 seconds to 20 seconds, the car maintained a constant velocity. There is no change in velocity at this time, and the acceleration for B becomes 0. Then from this point, it moves from 15 meters per second to 25 within 10 seconds again. So we can also calculate the acceleration for C. Then at this point, it decelerated or retarded to within, that is from 30 seconds to 50. It came down to 0 meters per second. So we can now calculate the acceleration for A, acceleration for B, acceleration for C, and acceleration for D. That is, we can say that for A, acceleration will be the gradient or the slope of this right angle triangle. The slope, that is a difference on the y-axis or change on the y-axis all over change on the x-axis. So in this case, we talk about change in V all over change in T, which is equal to 15 minus 0 all over 10 minus 0, which is equal to 15 all over 10, which is equal to 1.5 meters per second square. Then for B, since there is no change in velocity with time, the acceleration becomes 0. Then coming to this, from these points, let's consider this. The time difference is between 30 and 20. So we can say that the acceleration at this point is change in v all over change in t, which for the v we have 25 minus 15. 25 minus 15 all over. For this we have 30 minus 20. So we now have 10. 30 minus 20 is 10, which is equal to 1 meter per second square. Then the fourth one, we are talking about retardation. So the slope, this slope is a negative slope. So the acceleration at this point will become change in v all over change in t, which is equal to the change in v at this time. Let's look at this very well. Let's look at this very well. It's going to be 0 minus 25 all over. The time difference is 20. That is 50 minus 30. So this is equal to minus 25 all over 20. Can you see this? So we can use 5. 5 here, 5. 5 here, 4. So we have 5 all over 4 minus equal to 1.25. 1.25. That is equal to minus 1.25 meters per second square. So let's look at this critically. Here we have acceleration of 1.5 meters per second square. Here we have 0. Here we have 1. Here we have minus 1.25 meters per second square. So looking at this, for the journey from 0 to 15, we have the highest acceleration. And when you look at it, you ask yourself why? Why do the journey from 0 to 15 meters per second have the highest acceleration? Because the rate of change of velocity is the highest. Here you have 15, here you have 10, and that like that. So this one is even negative. So the highest acceleration is 1.5 meters per second